Thank you. Can everybody hear me all right? Well, hello then. I hope everybody's enjoying the conference so far. I'm really excited to be here. As was previously mentioned, I did fly about 7 hours to get here, and I've had less sleep than that in the last few days, so bear with me, please. Also, I put the deck of slides on SlideShare, and you can find it. I just tweeted it at WKF if that's something that's interesting to you. So I'm going to talk today about building hermetic systems without Docker. I'll explain why without Docker in a bit, and also all the other words on that screen as well. So first I'm going to say a little bit about me. Who am I? My name is Will Farrell. I'm a lead software architect at a software consulting company in Providence, Rhode Island. Mostly we build web applications, so we do a variety of different consulting. I've been programming for a long time, but I've been using Clojure professionally for about the last 4 years. Okay, so what can you expect to learn today? In addition to learning about what hermeticity is and what a hermetic system is, I hope that we can learn how hermeticity is an example of functional design thinking, one, how to identify leaks in not-so-hermetic system, and how to leverage Clojure to not only fix those leaks, but also to build and manage hermetic systems in general. So what are hermetic systems? Hopefully this image gives you a little bit of an idea what I'm talking about. Hermetic systems are airtight. They're sealed. That means they can run in isolation. They lack any kinds of external dependencies. And as such, they are pure in the sense of functional purity. They do not rely on global mutable state. And I imagine, as this is a Clojure conference, that's something that most people here will find very appealing. One second. Sorry about that. So now that we have kind of an idea of what hermeticity is and what hermetic systems are, why is this desirable? At a high level, hermeticity is a prerequisite for determinism. Man, I'm going to say that word a lot. I'm probably going to annoy myself with it at the end. I hope I don't annoy all of you. Anyway, I think of it as a prerequisite for determinism. For a well-behaved system, it should have well-defined inputs and outputs, and you should be able to run it the same way everywhere. You should be able to produce consistent results. So you could probably imagine at least one developer, probably yourself, saying something like this at least one time over the course of your career. You can imagine an application, maybe a web application, maybe your application. You've got a database, maybe Redis, maybe a message queue. Now imagine a new developer coming on that project. You've got to set up all the proper versions of all those tools. You have to seed the right data to get it to the right state in order for your application to actually have any chance of working. And how do you do that? Is there some series of arcane shell scripts that you need to run in the precise order that can only be gleaned through years of experience and pain? Obviously, this sounds awesome, but there actually are other alternatives as well that we might want to consider. Have I strawmanned this enough, or do you get my point? Which is that development environments are hard to keep consistent. And that doesn't apply just to development, it applies to testing as well. For continuous integration servers, it's not very uncommon to have bugs that appear only in one of two environments because there's some difference between the way in which the data is being seeded in your databases or because of the versions of the services that are running in these two different places. So you may think, after hearing the problems that I've just described, that Docker is obviously the solution, because Docker is the solution to all problems. It makes sense that you would think that's the solution to this particular problem. But as the name of this talk it suggests, I won't be shilling Docker here. And I do think, though, this is a valid question. Docker can solve a lot of similar problems. I mean, it can solve some of the problems that we're going to talk about today. Like, it does provide a way for you to create an immutable artifact that you can, like an image, that you can put your application inside and push to some repository and then pull that down on a CI server and run some code with some dependencies that are precisely the same on your machine as they are on CI and potentially in production. So we could certainly use Docker to manage our services and do some of the things I'm talking about today. So If your organization is writing and maintaining services in lots of different languages, if you have some special considerations when setting up environments, then perhaps Docker is absolutely the right choice for you. I have certainly used it and will continue to use it on projects, but recently I have been developing some small set of services that happen to be written just in Clojure, and I ended up with a better development experience when I can keep everything in the REPL and I don't need to rely on a separate service. I've also been bitten by Docker in a few of those cases where I have used it in production, and I don't really want to get into it because it's not about mocking Docker in any way. It's a really awesome tool, but if I don't have to add some particular layer of complexity to my project, I would rather not do it. And if I can stay in the REPL, I would much rather do that. I end up having more fun, which is a big part of why I do what I do. So yeah, we'll talk about that and fun today. Not to mention, Docker itself does not provide solutions to some of the other barriers that you'll need to push through in order to end up with a system that's really hermetic. So, am I implying that if Docker doesn't address all the barriers for hermeticity, do the techniques and tools I'm going to describe today? And the answer is no, because there's really no such thing. It's an ideal that we're seeking here. It's important to keep in mind that it's an ideal because we have to know from the get-go that there's never going to be a system that's perfectly sealed. I mean, you are writing Clojure code, you're going to rely on the JVM. It's totally possible that if you have a different JVM in one environment than another, that you're going to run into bugs that are a result of that discrepancy. Same goes for the operating system. Same goes probably for electricity, and you can keep going down farther about all the things that your code depends on. You need some hardware on which to run this software. So the goal isn't to make sure that your system is perfectly sealed, but rather it's to recognize the types of things that could leak, to fix the ones you can, and focus on the ones you can, and pick tools that help you to build those sorts of reliable systems. So this does raise the question, what kinds of leaks can we fix? I'm going to talk today about a few different kinds and some potential techniques. As always, it's important to ask yourself questions when you're building your own applications. Does this leak matter to me? Is the cost of fixing it going to outweigh the benefit I get from having this system that is reproducible, that is consistent in this particular way? And you'll have to think about it, but I hope that these questions can help you when you're trying to make those decisions going forward. So, external libraries, it's really hard these days, I think, to build anything without using some sort of external library. And I know that using a particular external library, I mean, I know in my day job we leverage open source software as often as we can. We save time, we save developer time, we save client money. There are lots of reasons why we're going to keep using external libraries, but there are also some costs. At the end of the day, it's code that's out of our control. Like, we need these, but we also need to understand what we're getting ourselves into when we do it. So what are the kinds of problems? I mean, we can just use line to install our dependencies, right, in all these different environments. Aren't the build artifacts that we push up to Clojure immutable? Why does it even matter? So sure, most of the time that's mostly true, but what happens if in your CI environment there's some transient network issue and you're unable to pull down your dependencies, and you needed some hot fix in production? Now you can't get that fix up to production potentially because you are unable to download these dependencies. And sure, there are things you could do like hosting your own set, dependency, your own repository somewhere. But at the end of the day, the fact that Clojure is running on the JVM means we have access to a pretty awesome set of solutions for this particular problem. I also wanted to mention too, if anybody here was familiar with the issue with left pad recently, I think that's an excellent example of probably a few different types of problems that could occur from using external libraries. So for those of you who aren't really familiar, a bunch of high-profile JavaScript projects broke because somewhere in their set of dependencies was a particular library called left pad, which is about as interesting as the name implies. It was an 11-line JavaScript function that padded a string. So one question that raises for me is, why do you need an external library for that? Was it really worth the potential risk of this dependency going missing to get this really awesome left padding behavior, which, as we all know, sounds extraordinarily exotic? Or perhaps could we have just written that ourselves? I don't know. Maybe it was a great reason for using it. But the other problem that it illuminates, I think, is we depend on these things. I mean, literally, it's in the name, so that should become, be fairly obvious. But what happens when this stuff disappears? Even though the artifact itself was immutable, the fact that it could be removed by the user made it so that when it disappeared, all this software broke. So in the case of, Clojure itself, we have jars. We can use Uber jars, and we can use line to package up all our dependencies, and then we have an immutable artifact that we can push to some server and then run on CI and then move it to production. And theoretically, all our dependencies are the same in all of these environments. It's pretty straightforward, I think, how one would do this. And honestly, I'm telling you this not because I don't expect you to be familiar with UberJar, but because it's really the most direct answer to Docker, when we're using Clojure. We create this immutable artifact, and it's existed longer than Docker and Docker images have existed. So it makes sense to me, if I'm in an environment where I can leverage this particular functionality, why wouldn't I, and why would I add another layer of complexity that I don't need? These are questions you have to ask yourself about your own environment and your own applications, but this is just something that's worked for me in the past. So, in a similar vein to external libraries are external services. For the same reason that we use external libraries, we tend to use hosted databases or third-party software as a service products or APIs that some other third-party hosts or provides for us, and we are introducing some level of risk to our service or our application. So again, we save money, we save developer time. There's lots of really great reasons why we would want to use these third-party APIs, but we're taking on risk that we have to be aware of and potentially mitigate depending on, say we have an SLA, say we have to, some particular level of support that we have to guarantee to our clients, if we have clients. We have to think about the fact that we have lost control of these services and things could happen out of our control. Not only that, but we have to think about development and testing, and we have to think about, well, now I potentially can't run even my test servers because this particular third-party API is down, and just say that API goes down, and now you're masking some real bugs because you're unable to run your tests because this third-party API is down. I'm painting a pretty bleak picture so that you agree with me, so I hope you do. So I think I just went into a fair amount of detail. Honestly, I probably should have gone forward to this slide while I was talking, but what's wrong with these services? Yeah, they can go down. The external bit, that's the problem. They're generally out of your control. They change over time. Different machines can have different versions. In the case of databases, even if it's not a hosted database, you still could be using one version of Elasticsearch and one version on your local machine and one version on a CI server. So there's also, there's the internal state that potentially needs to be synchronized. Like if you are trying to build some sort of system where you can reliably reproduce these results, but you've got this other third-party service whose data is changing over time, it might be really difficult for you to get reproducible results when there's essentially a big global variable that you don't have control over. Sorry, I'm talking kind of fast. All right, so should you rewrite everything? The answer's up there already. It's no, it's in parentheses, because why not? Generally speaking, rewriting everything is a bad idea. You don't want to have to pull in all these services and write them all yourself just because you're too xenophobic to use these external services. For some particular projects or where the risks are just too high, maybe that is a real solution for you, which is kind of why I mention it. But for most people, you probably don't want to do that. But there are some ways that we could potentially get some benefits of rewriting things, of pulling these external things internal, that we could see without having to actually rewrite anything. So one of those ways, I think, is embedding, which I'll talk about after a brief aside. So how many people here have heard about Stuart Sierra's component library? Seems pretty popular. Yeah, most people here have heard about that. I'm not going to cover it in too much detail because there's a talk coming up after lunch that I presume is going into a lot more detail about it. But to give you a little bit of context, Component is a library enabling a kind of functional dependency injection, helps organize your code base into small pieces called components, declare dependencies between them, and manage their lifecycle. Really the techniques I'm going to talk about here don't depend on Component, but it is a particularly good tool to implement some of these techniques, which is why I'm mentioning it here, and some of the examples will use component, so you should be at least a little familiar with it. So on that note as well, in components vernacular, your application, the collection of components in your application come together to form a system. You would typically have one in your application, and starting your application would be tantamount to calling start on your system. Fairly straightforward. If you can't read these code examples, it doesn't really matter, they're just from the component documentation. And like I said, I made the slides available if you want to look any more deeply into any of these samples or any of the ones that come in future slides. So, back for a second to embedding. So imagine a simple application here. Something that I made recently for fun was, it hits the GitHub API, and it counts the number of open pull requests for a particular project, and then indexes them in Elasticsearch. So now you have a time series of open pull requests for a particular project. I oversee a few different projects at work, and I was wondering if it would be a good idea, or if I could glean some useful information, if I could examine the number of pull requests over time and how quickly we close them. Basically, the mean time to closing a pull request is somehow correlated with the health of a particular project. My findings were debatable. I don't know if that's actually true, but it was kind of an interesting thing to track down, and I used it as an example in this particular talk. So we can identify at least two external services in that previous diagram. We can see that there was a GitHub service. We're depending on the GitHub API, and we're also depending on a hosted Elasticsearch. So this right here is an example of, a very small example, apparently, of a component that implements an Elasticsearch node that could be embedded in an application. So it also uses James Reeves' suspendable library so that you can not only start it and stop it, but when you start and stop the component, it won't actually kill the Elasticsearch node unless the configuration for the node has changed. So why is this useful at all, and how would you use it in a project? So basically what I want to do, and what the world that I want to live in for my application, is I want to only use the REPL for everything. I want to control all the services on which my application depends from the REPL. And so if I need to use Elasticsearch, at least to start locally, I want to, when I bring my system online, and start an Elasticsearch node that my application can use, so that everything exists in this tiny little bubble. So something that's more of a pattern, and something that I do because I'm comfortable with it, is to have a REPL namespace, a namespace in Clojure that's only really loaded in development, in development and in test. So you'll usually have your application's main system, and what I'd like to do, I like to think of it of taking that your main application system and then wrapping it in this other system that also includes dependencies that you're going to use in development and these test environments. So as you can see here, I'm loading component itself of some reloaded REPL helpers here, as well as my constructor basically for my embedded Elasticsearch server and my application itself. And so what I would do next is build basically this new system, this meta system almost, that wraps my application in development and in test environments, where I can add configuration for my Elasticsearch server, and then I can take the configuration, potentially modifying it from my application itself, declare the appropriate dependencies using Components API, and then start this new system that includes all of the dependencies that are outside the scope of the application as it might run in production. So this is sort of the jumping off point for me, because now, in that same namespace, I would tend to add, build up an API for interacting with my application as time goes on. So now you're not only just starting Elasticsearch, you can also write code in there about the seeding of Elasticsearch, or to set up some particular state, which leads to, it becomes much clearer and how one would set up development environment locally, because it's usually just one command, and also it provides some rails or some structure for people who want to add these sort of useful functions that could help out with development going forward. So things like re-indexing or seeding in the case of Elasticsearch. Like I said before, I really love to be in the REPL as often as possible. So if I can manage my entire environment from here using some functions that I wrote that I can keep also in the repository with the rest of the application code, that sounds wonderful to me. So you might be asking yourself, does this only work with services running on the JVM? And the answer is not really, not necessarily. There are a few projects out there, just as an example, for Postgres and Redis that essentially they seem to take platform-dependent binaries and put them in a jar and then shell out to manage the lifecycle of these services. Sounds kind of crazy maybe at first glance, but it also is a nice way to, I think, to manage the dependencies on those services, because you still get all the benefits of interacting with them from the REPL, even though they aren't technically services that run on the JVM. And that being said, there are tons of options for things that do run on the JVM that you could wrap up in a similar way. Here's just a short list of them. You've got Datomic and Zookeeper and H2 and Kafka and Elasticsearch, Neo4j, and there are more too. And it's generally not too difficult to wrap them up and create these embedded versions, and then you can provide configuration, potentially different configuration for different environments if that's important, and then use them in your application. So, as I mentioned before, there are really two external services for our example. There was the GitHub API itself. So, this one's a little trickier because it's unlikely that you're going to have access to some local copy of the GitHub API that you can run alongside your app, and let alone embedding one so that it can run inside the same JVM as the rest of your application. So, in cases like this, in order to handle dealing with these third-party APIs in a way that doesn't require me to actually hit the API in test environment or in development environments, I'm fond of making fake services. Basically, it has the same interface and would export the same interface that the GitHub API would expose, but could return fake data, or could return data, not just fake data, but maybe fake data that meets some certain criteria or some set of constraints, which could be useful in some sort of testing or development environment, because it lets you basically control the state of this external version, maybe to trigger a bug that you're trying to debug in a particular environment. That being said, it's also can be a lot of work depending on the complexity of these APIs. So you have to think, is it really worth it? Like, what are some other alternatives that wouldn't require you to make this HTTP API that is compatible with GitHub? So another option would be to swap out one of the components in your application when you're in development or in a testing environment, and use some fake GitHub API client that just returns data. This way of doing it might be better for you depending on how important it is for you to exercise the code that hits the GitHub API. Like, if you're using some standard GitHub client and really all you're buying by using this fake server is that you get to exercise the code from this other library that's theoretically already tested and maintained, it might actually be better to just make the fake GitHub client and return the data you need. Then the rest of your application can get the data mocked up in the same way that it would be if you had built a fake server, but with less work from maintenance for the developer. Really, it depends on your tolerance for risk here and how important it is to fully exercise all the different pieces of your system. I mean, in the case of the GitHub server, you still have to worry about things like, what if their API changes and my tests still pass, but I fail in production because I'm not staying in sync with their API? Theoretically, I could imagine a case where you built these fake servers from some sort of specification, and the specification would allow you to not only build this fake server, but also test against the real server to make sure that you stay in sync. Like, you can use the spec to validate requests to the actual API, and you could use it to generate your fake requests. That's kind of an ambitious undertaking, so you probably would want to have a good reason for doing it, or it could be a fun open source project that someone could work on. Not me right now, but one of you for sure. So, is that it? No, it's not. I was just taking a drink of water in case that was confusing. So by now, though, we do have a pretty good idea, I think, of how to handle generic external services, both in the case of things like databases as well as third-party APIs. They don't have to be HTTP APIs. You can imagine other interfaces that you could mock up and expose in a similar way. So this is going to get us pretty far towards creating some applications that can run in a sort of a sealed way where you can reproduce results in one environment and in another environment. But I think there are a few more things that are maybe less obvious that could also trip us up. So one of those things is entropy. So besides the fact that I think it looks kind of cool to have a single word slide on a dramatic purple background, I think it also could be problematic for us when an application, in order for some business reason, needs some degree of pseudo-randomness. So cryptography is one domain that might jump to mind where this is important, but there's also elements of randomness in everything from sorting algorithms to generative tests to creating identifiers. So that makes me think, well, is there something wrong with entropy? I mean, entropy is fairly sensitive. Do I want to risk hurting its feelings? And really, no, I don't. There's nothing wrong with entropy per se, other than the difficulty of reversing it. The problem, though, is where it comes from in our application. So where do we get entropy? Sources of randomness often are as varied as their applications. So mouse clicks, key presses, audio signals, machines that could have potentially dedicated hardware. And at first blush, this may seem at odds with our quest for determinism, but this too is something we can handle. And in fact, we saw how to handle it already in the previous talk on one of the slides, because really what we want is a random number generator that can take a seed. We want to take this random number generator, instead of making it this process that depends on some global state that we don't have access to, turn it into something pure. So in this example up here on the screen, we're using Java util random, which can accept a seed value, and then we're returning some lazy sequence of numbers that are generated randomly, but in a way that is reproducible. So if this is something that's really important to your application, that you can have a service run on two different machines in two different environments, generate random numbers, and those random numbers be exactly the same ones that are generated, then you might want to think about designing your application around it. I could imagine you creating an entropy as a service or randomness as a service in your application, maybe a component that you could get random numbers out of. And then other services that depend on this randomness could get some of those random numbers when they need it. And when you're starting a service in another environment, then you could get the same set of random numbers. You don't even necessarily have to use a seed value in production, because I won't get into it now, but it might be a bad idea, depending on how the random number generator works, to use one that you can seed in that way. But you could use it in environments where that was important to you, like in development or in test environments. So, excuse me. So I'm imagining it right now using this random service. In retrospect, I probably should have thought of a better name for it. But I'm thinking now, what happens when multiple components need random numbers? So what happens if, for instance, every 5 seconds, each of 3 components needed a random number? Would the application still be deterministic in that case? I ask you. Not expecting an answer. So the answer to that previous question, along with most good answers and good questions, is that it depends. In this case, it depends on time, and it depends on some factors that we haven't talked about here. So what's wrong with time here? So if each of these 3 components that needed random numbers had their own timers and they were unsynchronized, there was no synchronization in any way, then no, the application is not deterministic, because we cannot make any assertions about the order in which we're pulling random numbers from that stream. So even if the stream was the same on all these different machines, if we have 3 things pulling numbers from this stream and they're potentially pulling in a different order, then the application could have different results in different environments. So really, we've just revealed another global dependency on something outside of our application, which is the system clock, potentially. So more broadly, if our application depends on the system clock at all, there's a good chance it's not deterministic. Imagine a simple example of an application that, for whatever reason, deletes all the records in your database every 30 minutes, like on the half hour, and your test suite takes 20 minutes to run. And so you run your test suite on CI, and sometimes in the middle of your test suite, all your data is deleted, and sometimes the tests pass all green. It's not a very good application. I would probably remove that. This is a contrived example. Like, it's most likely a bug if that's happening, but it's how you end up with test suites that are green sometimes and red on other times. And I hope that you can see that the problem here is from the way that we're informally modeling time and from this dependency on something that is outside of our control, and how it can cause problems that aren't immediately obvious. So the answer is just using datomic, right? Like, I read half an article once, and it said datomic had something to do with time, so that's probably the right choice here. That's how I think it works. I'm also just kidding. I mean, datomic is an excellent tool for certain problems. It's not really what I'm talking about here, but I mention it because we do have to think like datomic in some ways. We have to think more formally about time. So let's talk a little bit about how we could do that. So to fix our problems, we have to think more formally. I said earlier that hermetic systems are like pure functions. And so in this case, we have to think, what are the additional inputs that our function needs in order to be really reproducible and sealed? So I think that what we really need is, we need to say, not just that we're running our application in some sort of loose terms, but we're really saying we're running it from time A to time B. You know, that's a more precise way to describe what's happening for our application. We need to take it and divorce it from the system clock. Now, how could we, with that grounding and the theory, how could we actually build a system that did that? So let's say, for starters, that we agree to use some abstract unit like a tick to talk about start and end times, because a clock ticks, get it? We should also probably have only one clock and pull it inside the umbrella of our application. Then any other clock-dependent components in our application need to provide some way to express what needs to happen on each of those ticks, and then the clock for each tick from A to B would call on tick for each of these components that depend on the clock, and then this would make your application totally independent of the system clock, which is kind of interesting, and perhaps needlessly complicated for most applications. Some of you may recognize that what I'm essentially describing, though, is simulation, which happened in the last, where there was some talk about in the last presentation here. Like, basically, we're setting up our application to be simulatable. And if you don't have some strict modeling of time, it would be really difficult to, for instance, run a simulation that ran double time, that basically took an hour's worth of work and ran it in a few seconds. Like, if you needed to, say you had some sort of scheduling algorithm that you were testing that had some complex relationship between these input events and then the output events, and it took hours to really see how the algorithm was functioning, it would be really difficult to test that unless you had taken the time to design your application from the very beginning in the way that you handle time. So for most situations, this is probably more complexity than you really need in order to make a stable application. But say you were designing a complex scheduler, and you had to think about the second derivative of certain functions because of the way that the cluster utilization was slowly changing over time. And if you wanted to model that kind of behavior, you'd probably want to think about how you're modeling time, or else you're going to end up in a situation where it's going to take a really long time to test out any particular changes to this algorithm. So that about wraps up time, and I can take off my Dr. Seuss hat and stop talking about ticks and clocks and talks, but I hope you kind of see where I was going there. So is our system perfect now? We've controlled entropy, we've controlled time and services and external libraries, and as I've mentioned probably about 3 or 4 times, no, we're never going to get a perfectly sealed system. It's just not possible to do such a thing. But if you ask the right questions and evaluate trade-offs and make good decisions when you're thinking about designing your application, it's possible to end up with a good trade-off where you have a system that is sealed enough to have some practical value in a development environment or a test environment. And you can realize, the benefits of those particular decisions that you made. So what did we learn? Hopefully we learned a little bit about how to evaluate these systems and find leaks. You can probably think about systems that you've worked on and difficulties you've run into when trying to run certain types of tests, or maybe you've had an integration test suite that only stayed green for about 3 to 4 minutes at a time, and you were wondering why did this happen, and then you realized that it's probably Selenium's fault, but there's probably a good reason, that you could, or a good way that you could have built the system in the first place to avoid those situations where you introduced this non-determinism that made your test suites so hard to keep green in the first place. I hope we learned a little bit about how to plug certain types of leaks. I mean, there are other ones as well, but hopefully these are some practical and common ones that provide enough value that you got something out of it. And I also hope that we learned a little bit about making good trade-offs in general when we're building these hermetic systems. When you keep in mind that your goal is not to create something that's perfectly sealed, but to create a practical balance between the amount of work maintaining the system and the amount of value you get out of it, I think you can end up with a reasonable system that is easier to maintain as a result. So I spoke kind of fast because I'm nervous, but does anybody have any questions?
So we have 5 minutes for questions. Anyone? Yes. That is from one of the organizers.
Hi. Most of your examples are about development and testing. So I was wondering how much hermeticity you would recommend to use in production.
Well, you have a different set of challenges, I think, in production. So we were talking about, for instance, what happens when the GitHub API goes down in development and testing. Like you lose some productivity and you lose your ability to test your application. And really, you're tying your tests and the correct behavior of your application to something that is out of your control, which is undesirable. But if your production application depends on systems that are out of your control, then really I think you need to expand the definition of your system to include GitHub as well. So I don't know that there's any getting around the fact if you decide to tie yourself to a particular API that your reliability is going to be tied to their reliability. If there's some way, maybe with using a different example, like there were multiple different services that provided similar data, and then you could build your system so that you hit multiple services and there was redundancy on a different level. Yeah, basically, I think that you end up solving different problems there, which are interesting in their own right, but maybe addressing a different topic. Sorry, I hope that answered your question.
Any other questions? Yes.
Thanks for the talk. When you embed Postgres or Elasticsearch or all these things, doesn't that mean that you are not doing what's actually in production? Because I guess you don't do that in production, right? You just...
Yeah, I wouldn't do that in production. I would probably only do that in development and testing environments. But I know, too, that I have... this is probably maybe not a good idea, it's debatable, but if you have a really, really small system, like a prototype that you're spinning up, and the data doesn't really need to stick around, I have actually pushed it to a production-like environment where users have had access to it, but I didn't have to spin up some additional database because I didn't really care about the data. I mean, it's really about the system, about your risk tolerance for your particular application. So, yeah.
Okay, thanks.
Okay, one last question? No? Okay, thank you, Will, and this is our token of appreciation.